In this recording, I'm going to demonstrate how to create a report. Clicking on reports here. We're going to create a report, two reports, one for the species levels or reactant levels, and the second will be for the reaction fluxes. So I click New over here, and you see this shows up. When I click on the number to the left of that, it takes me to this panel. I'm going to call this report Levels. You see that the task it's going to receive the information from, the data from, is time course. You can put comments. I usually don't. Here we come to item, and the first item we're going to add is the model time. Then second item, I go to species in this case, and the transient concentrations. When I click on this, it will include all the species listed in the model. If you want to pick and choose separate ones, you can expand it and get those, but I like to just do this by routine. Then I can generate a template. Everything happens the same way, in the same place, same structure every time I run this report. I don't rearrange the sequence in here. I do all that outside after the report has been dumped into templates, database systems, whatever it may be. For example, I can take sync and move it up or down. So you could pre-organize your report if you wanted to do it that way. For my purposes, I found it better just to use database systems externally to capture all of these and sort them into the pathways and arrangements that we want to evaluate and assess the species report, in this case the species levels. We commit. You saw it move on the left over here, and we have a new report called Levels. Now I'm going to click New here, and we see the GUI, Graphical User Interface, with COPASI has many ways to accomplish similar tasks, which makes it really user-friendly. This one we want to call Flux. This is reaction flux. Again, the task is time course. Come to item. Again, we want model time. And then item again. In this case, we're going to reactions, and we want the concentration fluxes. There might be times where we'll want to do particle numbers if we want to do other calculations, such as if we're working with ion species across a membrane, we might dump this so that we could calculate capacitance or some other value such as that externally. And we click OK. And note, because the way that I've labeled the reactions in this model, the reactions are all in order, which is convenient. Makes it much easier to generate the templates offline. But still, databases can be used to use this information to sort the results very quickly. And we have it checked here for the title row. That's gives us the top row. These become the titles of the columns in our report. And you notice here that by default it is a tab separator, which is fine. And we commit. I like to save as often as I can. And now when we come to time course, you can watch the previous video on how to run a simulation, but here we go again. We now see our specialized reports on here. I have a demo folder for these demos now. Let me just pull it in here. And again, in this case, we might use the specific name of the sample or individual subject, whatever the code is. GSE 1, 2, 3, 4, 5, whatever. This again, which one did I choose? Levels. So I like to put levels in there. January 2013, and the time 2:08 p.m. You may run several ones where you've changed certain things. All this naming becomes key to track. If you don't change the name, then everything is overwritten and you lose all your results from prior runs. Make sure your append box is unchanged unless you want to create this continuous model. But notice up here we've got 1,000 intervals, so we're going to have 1,000 rows in our report. We confirm, click run. This time I'll just let you see the scroll as a timer up in the top left. You see some of our graphs that are being generated simultaneously. I'll do another video to show you how to generate these graphs if you wish to have, or plots if you wish to have them included. Now that we're dumping all the levels for all these species, it's running a little bit more slowly than you noted in the previous video where it was a smaller set of results that were being dumped. You can see here suppress output before, so we can just dump the last 20 minutes. In this case, 20,000, whatever the units are here. In this case, we see that there's important information at different times during the duration. Some events are shaped differently. So in this case, we want all of our time point because we have a temporal response. There are decisions made like that related to the size of the data files that you dump. Your temporal resolution is determined by intervals and interval size in here and relevant to the duration. You saw that duration is critical, so I get a completed event. I return to baseline after exposing this simulation in silico to a drug. Now we've completed that run. We typically run both levels and flux. I switched to the flux. I misspelled my title there with double L. And I changed the name of the file. By default, it's going into the same folder in which the COPASI file is in. Previously I did the browse, but I know by default it's going to go into the same location. If you click browse here, COPASI assumes that you're going to create a new file name, so it will erase what's in the box here. So just little things like that become apparent as you use the model. And we click run. And it'll take a similar time. Now we're dumping the flux results into the model. Let's look at I was looking at the graphs to see if I had a flux plot there. Okay, then these can be opened. I'll do another recording to keep this as short as possible. I'll do another recording on opening these text files.